Today we are going to discuss about a very important topic of class 10, which one is quadratic equation. Now what is the general form of quadratic equation? Ax square plus bx plus c equal to 0, where a should not be 0. Why a should not be 0? Because if a is 0, then this x square term is vanished. Then it becomes bx plus c equal to 0 if a equal to 0. And which one is linear? That's why this restriction it must be imposed in the quadratic equation. Suppose an example, 2x square plus 3x plus 4 equal to 0. This one is an example of quadratic equation. Now if this term is vanished, 2x square plus 3x equal to 0. This one also quadratic equation. If this term vanished, 2x square 4 equal to 0. This one also quadratic equation. Because our intention, what is the maximum power of x? Maximum power of x is 2 in every equation. But if you vanish this term, it becomes 3x plus 4 equal to 0, which are not quadratic. This one is linear equation. Now our main focus in this chapter, how we can solve this quadratic equation. We can solve this equation by two ways. One way is factorization. That is, if we can factorize this equation, then its solution is very easy. That is when ax square plus bx plus c equal to 0, and if you factorize this equation, it becomes like this, x minus alpha into x minus beta equal to 0 in this form. And from here you can easily say either x minus alpha equal to 0 or x minus beta equal to 0, that is x equal to alpha or x equal to beta. So here alpha and beta will be the solution of this equation, and we say here alpha and beta are the roots of the equation. Alpha and beta are the roots of the quadratic equation. As it is a quadratic equation, so you can get at most two roots, maximum two roots you will get. If we give an example, suppose x square minus 5x plus 6 equal to 0. This one is a quadratic equation. You can easily factorize this term. Middle term factor you know, x square minus 3x minus 2x plus 6 equal to 0. This one becomes x minus 3 and x minus 2 equal to 0. So you will get either x minus 3 equal to 0 or x minus 2 equal to 0. That is x equal to 3 or x equal to 2. So 2 and 3 are the roots of this equation. Now it is not possible every time that you will factorize the equation. Suppose if I give an example, 2x square minus 6x plus 1 equal to 0. This one also an quadratic equation, but you can factorize this. Then what can we do? So when you can factorize the equation, then we have a general solution given by Sridhar Acharya. This formula is very well known formula, Sridhar Acharya formula. Sridhar Acharya formula. What is the formula? This formula is x equal to minus b plus minus root over b square minus 4ac by 12. That is, when you given a quadratic equation and if you can recognize what is a, b and c, that is the coefficients of the equation, you can easily solve the equation by using Sridharacharya formula. Which one? What is this one? X equal to minus b plus minus root over b square minus 4ac by 12. That you just here in this equation, a equal to 2, b equal to minus 6 and c equal to 1. Always write the value of the coefficient with proper sign. Here a is 2 but b is not 6, b is minus 6 and c equal to 1. And if we put the data in this equation, x equal to minus b, that is minus of minus 6 plus minus root over b square minus 4ac, a means 2, c means 1 by 2a, 2a means this one. So we can easily calculate. This becomes 6 plus minus 6 6 is 36 minus 8 by 4, that is 6 plus minus 36 minus 8. 36 minus 8 means 28 by 4. And what is 28? Root 28 means 7 4 is 28. So 6 plus minus 2 root 7 by 4. You can cancel by 2, that is 3 plus minus root 7 by 2. So here you will get two solutions, x equal to 3 plus root 7 by 2. Another is x equal to 3 minus root 7 by 2. These are the two roots of this equation. So if you can't factorize the quadratic equation, you will use Sridharacharya formula, minus b plus minus root over b square minus 4ac by 2a, then you will get the solution. Now x equal to minus b plus minus root over b square minus 4ac by 2a. In this solution, the most important part of the solution is b square minus 4ac. This one is called discriminant of the equation. Discriminant. And it was denoted by capital D. What is determined? It's determined the nature of the root. That is, what will be the nature of the roots of the given equation, whether they are real, whether they are not real, that is imaginary. If they are real, whether they are distinct or they are equal, we can easily understand from this term b square minus 4ac. What are the conditions? First condition is d equal to b square minus 4ac is greater than 0. If this calculation, when you calculate b square minus 4ac, it is positive, then you can say roots are real and distinct. That is, you will get two roots and they will be real number and they are distinct. In the previous question, you get two real roots, 3 plus minus root 7 by 2. Now, if d equal to b square minus 4ac equal to 0, then roots are real and equal. When the discriminant is 0, roots become real and equal. And third case, d equal to b square minus 4ac less than 0, then roots are imaginary. You see, when this one is negative, this is the square root of a negative number, which is not possible in real number. So when b square minus 4ac is negative, you can't get the roots of the equation in real numbers. The roots become imaginary. So these are the three conditions, b square minus 4ac, where we can understand the nature of the roots without calculating the roots. Just calculate b square minus 4ac, whether when this one is greater than 0, the roots are real and distinct. When this one is 0, the roots are real and equal, and this one is less than 0, the roots are imaginary. Now, relation between the roots and the coefficients. The roots and coefficient and their relation. What are the relation between them? Use when you write ax square plus bx plus c equal to 0, and we are when solving this equation, this becomes this one x minus alpha and x minus beta equal to 0, and you get x equal to alpha or x equal to beta. They are the roots. Now, what are the relation between alpha, beta and a, b, c? That is our question. Now, we get this factorization from this equation. So, this will become equal to this, that is ax square plus bx plus c equal to x minus alpha and x minus beta. If we compare both sides with the coefficient of x square or coefficient of x, then we can easily understand what is the relation between the roots and the coefficient. If you multiply this one becomes x square minus alpha plus beta x plus alpha beta. For comparing this one, we divide this equation by a. This one becomes x square by b by x plus c by a. Now, if we compare the identity, this one is an identity, you easily see alpha plus beta equal to b by a and alpha beta equal to c by a. This one we can write alpha plus beta equal to minus b by a and alpha beta equal to c by a. That is the relation between the roots of the equation and the coefficient of the equation. That is sum of the roots alpha plus beta equal to b by minus b by a. What is this one? This one equal to coefficient of x by coefficient of x square. What is this one? This one is constant term by coefficient of x square. That is alpha plus beta equal to minus b by a and alpha beta equal to c by a. This is the relation between the roots and the coefficient, and from where we will get this you can easily understand. Now this one also one important thing, if alpha beta, this was a backward thinking, are the, if alpha beta are the roots of a equation, then what is the equation? Then the equation become x square minus alpha plus beta x plus alpha beta equal to 0. This one is a backward question. Always you have given quadratic equation, you solve them and you get alpha and beta. Another question, you are given alpha beta, that is roots are given, then what will be the quadratic equation? Now this become x square minus sum of the roots into x plus product of the roots. So clear, these are the all about the theoretical part of quadratic equation. In the next class we will elaborate this theoretical part with some efficient example, so then you can easily understand about the chapter. Thank you. See you in the next video.